I had heard that there was a local string figure enthusiast named Greg Keith, who was also a well-known poet, computer geek, and I heard that Greg had been teaching giant string figures, which are this folk art form made with a loop of string, like Cat's Cradle or Jacob's Ladder. He had been teaching these using big ropes, loops of rope, to local dancers, and he'd had them perform some of these traditional string figures. So I invited Greg to come to a rehearsal with Scott and I and the third dancer, Barbara Susko, and we started to learn some of these giant string figures. And we decided to make an entire show through the loop around the idea of loops of rope, loops of string, storytelling with string figures, and so on. As part of that, we started, Scott and I started to talk about and explore ways of making shapes that would say to us, in this era, mathematics say more than the traditional figures. Now, traditional string figures are very mathematically complex and amazingly difficult sometimes to construct. But we wondered about making polyhedra with loops of string. And Scott came up with these very nice ways of making a tetrahedron and an octahedron, which we then morphed into a cube, and some other shapes that are polyhedral or three-dimensional. That, in a way, became, for me, a mathematical question. And this is how sometimes things go. Sometimes we'll take a mathematical idea and see what happens when you put it on stage. Sometimes from things on stage or in dances or choreography, we'll get an idea about mathematics and try and explore that more mathematically. As Scott once said, this became a research project for me, and I looked for ways of making all of the Platonic solids, 5 basic polyhedral shapes with strings. And in a sense, I thought about origami in a strange sense. Origami traditionally is often very flat, two-dimensional, and it often represents animals and people and everyday objects, though sometimes abstract things. But contemporary origami is modular, and people who do it often use many of the same shape put together to make complex three-dimensional, not two-dimensional objects like polyhedra. And so I wondered, well, can you do the same thing with string figures? Traditional string figures are often flat and two-dimensional and represent animals or people. And so that led me in this mathematical exploration to thinking about using multiple loops of strings as modules that could be used in the same way, much as people do in modular origami. And I wondered whether we couldn't do the same thing with string figures, and came up with ways of making all the Platonic solids with 4 loops and with 6 loops. The 6-loop one has become popular. It uses 6 loops of 3 different colors, and it's a particularly easy one and surprising one to do, and it's become something that math people have passed along by hand from one group to another. It does take a group, because the dodecahedron, for example, has 20 vertices and takes 10 people. And it's not a dance, because the people are just crowded around this shape, and you can hardly see it unless you're standing on top of them. But it did grow out of the mathematical dance work.